Welcome to EDU World Space.
Problem 3.143. In this problem, we have to replace this range system by two forces acting at point A and point B that is perpendicular to y-axis. So let us say that F1 is acting at point A and F2 is acting at point B. Alright, so since these two forces are perpendicular to y, so their component along the coordinate axis will not have any component in y direction. So F1 can be written as F1x I cap plus F1z k cap, while similarly for F2 we can write F2x I cap plus F2z k cap. Since they are perpendicular to y axis, so there will be no j cap component. Now if we draw a rough diagram for these vectors, so let us say this was our coordinate axis y axis, and this is x axis, and this is z axis. Alright, so here at point A, one force F1x is in x direction, and here F2x is in x direction, F1z is in z direction, and F2z is also in z direction. So this was the point A and this was point B. This perpendicular distance was given as A and this perpendicular distance was B. So now we can apply the force balance and moment balance in this problem. So we see here that the only force is along z axis. It means that the sum of the forces along x axis should be 0, and since there is no y component, so we need not to worry about the y component force balance. So for x axis direction we can write it as F1x plus F2x must be 0. This gives F1x equals to minus F2x. Let us say this is our equation 1. Now if we balance the forces in z direction, then both the direction are in same direction, and that is the same direction of r. So we can write it as F1z plus F2z must be equals to r. Let us say this is our expression number 2. Now if we write the force balance along x axis, so since this F1x will give moment along z axis, so we can write the moment because of this F1x about z axis. So mz, if we calculate in equivalent diagram, and that will be because of F1x, that is F1x into A, and its moment will be along negative z direction, so we have to use sign negative here, plus because of this F2, again the direction will be in negative z direction, so it will be minus F2x multiplied by the distance, and distance from the x axis is going to be A plus B, and this moment should be equal to the moment that was present in the actual system, and that was m. So from here we can write it as F1x A plus F2x A plus B equals to minus m. Let us say this is our equation number 3. Now this F1z and F2z will give moment about x direction, so we can balance moment along x axis, and that will be because of this F1z, the moment will be in positive x direction, so it will be F1z multiplied by A plus F2z multiplied by A plus B, and moment in actual diagram in x direction is 0, so this must be equals to 0. So from here we can say that Okay, we can use this expression that is from equation 2. Let us say this was our expression 4. So we can put the value of f1z from equation 2 in the equation 4. So from here we can write f1z equals to r minus f2z. So we can put this expression in equation 4. So this will be f1z. So we have to write instead of this fr minus f2z multiplied by a plus f2z multiplied by a plus b equals to 0. So from here we can get the value of f2z. So this will be ra minus a times f2z plus f2z into a plus b equals to 0. So from here we see that if you multiply f2z with a, so this is a into f2z, and this is minus a into f2z, and this will be plus a into f2z. So we can cancel out these terms. So ra equals to, if we ra minus ra equals to f2z into b. From here we can say f2z is equals to minus r times a upon b. So this is the expression for f2z component. So now we can use this expression and put the value of f2z. So we can get the value of f1z. So f1z will be r minus f2z, that is equals to r minus, and minus sign was already there, so it will be plus r a upon b. So this becomes, if we take our commons, comma 1 up plus a upon b. So f1z has the value r times 1 plus a by b. Alright, we have made a mistake here. So no, it's correct. So this is the expression for f1z. We got two values, and we have to find other two values. So we can use now this expression number 3 and expression number 1. From expression number 1 we have got the value of f1x is equals to minus f2x. So we can replace f1x here in so putting 1 in equation 3. So if we put the value of what is the equation 3, it is f1. So we can take these values and we can write it here, and we can replace this value f1x by minus f2x. So from here we can get the value of f2x. So because we can take comma f2x, so it will be minus a plus b is equals to minus m. So f2x comes out to be minus m upon b. Now if we got the value of f2x, so from equation 1 we can say f1x will be negative of f2x, so it comes out to be m upon b. Hence our vector, since f1 was written as f1x I cap plus f1z k cap, now we have got the value of f1x as m upon b, so it will be m by b I cap, and f1z we have got the value here r times 1 plus a by b, so it will be plus r times 1 plus a by b k cap. So this is the expression for f1, that is the force that is acting at point A, and for the force that is acting at point B, that its component will be f2x I cap plus f2z k cap, and we have already calculated these values. Here f2x was minus m upon b I cap, and f2z we have calculated above, and this was here minus r times a upon b. So this will be plus minus r times A upon B K cap, which comes out to be minus M upon B I cap and minus r times A upon B K cap. So this is the expression for F2, that is the force that is acting at point B, and this is the expression for the force F1 that is acting at point A.